Hello and welcome to the next video in the series. In this video, I'm going to talk about the key to actually writing good and stable code. This is something that I had to learn in the job market. It's not something that you learn in school so much, and it's probably the most important lesson if you are thinking about becoming a professional programmer, and that is to write good tests. And this is my personal opinion. I'm not sure that everyone would agree, but in the years that I've worked, this has been key difference between developers who are really good and developers who struggle a little bit when it comes to code, especially as the project gets bigger and bigger. We're going to understand why this is very important and why I'm trying to teach this at the very beginning when we actually get into some code. So let's just do that. So over here we have the code that we wrote in the previous video, the self-checkout class and the ATM class. Up to this point, we've been testing if our code works correctly by printing out everything in the console and then checking it every time we call the function. And this is not how things are done in the actual real world when you're programming different products, because you can't keep checking everything by printing stuff because first of all it takes a lot of time, and second of all, imagine if you have 10, 20, 30 people working and everyone is just printing stuff on the screen. That's just not how things work. So there needs to be a better way of actually testing your code. In a lot of projects, it turns out a lot of people don't actually write tests, or they just write bad tests because they don't believe how useful they are. But if you want to have a laid-back developer experience, the better you get at writing tests, the better your code is going to be and the less work you have to actually do. So let's learn how to actually do that. So in the project that you have, you can right-click on your project right at the top. I've called this one Intro to Test. You can work on your previous one if you want. You can right-click here and then go to New, and then choose Directory here. And we're going to call the directory Tests. And you'll get a new folder on the left pane of your window. You can right-click this folder and then go to Mark Directory As and mark it as a test root. All this does is it changes the color of the folder for you, and then it lets IntelliJ know that all your tests are going to be in this folder. So now let's actually write some tests. Let's right-click on this test folder, and then we can, there's two ways we can do this. So one way is we can create a new Java class and then call it ATM test, and then we can create the class. The other way is you can go to the class that you're writing a test for. So let's say I choose this ATM. If I just click on this ATM, there will be a yellow light bulb that appears here. I can click on it and then go on Create Test and just click on Create Test. And then it's going to go automatically to your test folder that you created. So if I just click OK right here, if I go into my test folder, we'll see that it created the class for me. So you can go both ways as you like. The second thing we need to do is I want to talk about this import statement here. It's something that we haven't talked about before. So we've learned about classes and functions. And one thing that we can do in programming is we can use the tools that other people have created to use for our own programming purposes. Whenever we want to create tools, we want to use the other tools, we need to import them. So that's what this import statement means. And the reason it's red is because this is not actually, we need to add the code that we're using into our project as well. And you can do that by again clicking on the red bulb here. And we want to use JUnit 5.7. So you can just click on Add JUnit 5.7 and just press OK when this opens, and this will just add it to your project. So now we can actually get into writing tests. We need to add the public in front of this, in front of the class. And now we can actually write tests. So the way you write tests is you write add test like this. and then you do public. One thing to make sure that happens whenever you're add test, IntelliJ will give you a suggestion to click the test, so you can just press enter on it and it'll import that specific functionality into your IDE. We will learn more about these as we go on, but basically every tool that we use, we need to tell IntelliJ where it's coming from. So let's write a test. Again, every test we need to start with public void, because the test results don't return anything. And the format I try to follow whenever I write tests is when something, then something needs to happen. So in the case of our ATM, let's think of a scenario. So whenever we deposit $100, there should be $100 in our account, right? So that's how we actually did our test before, when we printed out the results on our screen. So that's exactly what I'm going to write here. So when deposit 100, then account balance is 100. So it's important when you're writing tests that you write very descriptive test cases. So you want to write when something happens, then something should happen. And then you can just open parentheses, close parentheses. You don't need to have any input inside of it. Now we need to actually write our tests. This is very similar to what we did in the main function. So we say ATM. And again, I want to showcase this. When you can click enter for IntelliJ to automatically add this, and then you give it a name, and then we initialize our ATM. And if you remember, we don't need to give it any input variables. Now what we want to do is we want to deposit 100. And now what we want to do is over here, if you recall, whenever we did the view account balance. So over here, if you recall, whenever we had view account balance, we printed it onto screen. So I changed that so we don't print to the screen anymore, because we learned that that's not how we do things. Instead of I'm just returning the amount that's stored in account balance. So I'm no longer printing it anymore, because that's not how we're doing things from here on. So now in my test, what I want to do is I want to ensure that when I check the account balance, it's equal to $100. So the way you do that with the test is you write assertions, and then you say assert equals. So what this means is this is a function that you can just copy, and that's why we imported this library here. And what we want to do is we want to say make sure that it's equal to 100 whenever we check our account balance. So this is what the expected value is, and this is what the actual value is. So what we're saying is make sure the actual value is equal to the expected value. So if I actually run this test, what we're going to see in the bottom here, it shows us that the test passed, meaning that when we deposited 100, we actually have 100 in the account. So if I actually go into our code and let's say, by accident, instead of actually whenever I was coding this, or another developer came and coded, and they accidentally put the deposit amount +1. So not only are they putting the deposit amount, they also add a +1. When we actually go to our code, when they go to our tests and they run the test, they're going to see the test didn't work. It's not going to be green anymore. And they're going to come here and they're going to see that the expected value is 100, but the actual is 101. So something went wrong. So this way you are protecting your code and protecting that developer from making a mistake, or even yourself, right? Maybe by accident you did something and you want to know what went wrong. And then that's why the name of the test is so important, because it tells the developer who is coding this that what this test is actually trying to do, and it's easier for them to check, fix it and identify the problem. A lot of the times in big companies with big code bases, whenever there is a problem or an issue, a lot of their time is spent trying to find out what the actual problem is. Whereas if you have tests, you're able to catch it right there and then. All right, so let's fix our code here and remove that +1. And then we can run our test again, make sure that everything is okay. All right, great. So now let's write another test. So you can take a crack at it. We want to write a test to check the withdraw functionality in the ATM. So I'm going to do pub test, and then again we start with public void, and then we say when withdraw with funds available. So if we withdraw and we have funds available, then reduce by withdrawal amount. Don't be afraid of making these names long, as long as they make sense. Believe me, you will later thank yourself, or the developer working on your code will thank you when they see how descriptive your names are. So again, I'm going to write ATM, and I'm going to initialize a new one. And to make this work, since whenever we initialize an ATM, we have 0 in our account, so I'm going to deposit 50 dollars, and then I'm going to withdraw 25. So what should be the result? So let me add the assertions dot assert equals. So when you deposit 50 and then withdraw 25, what's the expected value? It should be 50 minus 25. So what we're expecting, if everything is working properly, the answer should be 25. And let's actually check what our actual account balance shows. So view account balance. And if we've done everything right in our code, this test should pass. And you can see it's all green. That means that when we wrote our code, everything is right and it's working. We can write one more test for our ATM, and this last one we're going to say what happens when we actually try to withdraw funds when we don't have anything. So the way we have written in our code, if they don't have enough funds in their account, they shouldn't be able to withdraw. So again, we're going to give it a very descriptive name. We're going to say when withdraw with no funds, then account balance, no change. So whenever a developer comes and reads the name of our code, they understand that until now, whenever they withdrew funds, when they withdrew the amount that wasn't available in the funds, then the account balance shouldn't change. So we're going to do another test. We're going to say ATM. And then again, we're going to deposit. Let's say we're just going to deposit 10. And then we're going to try to withdraw 100. And then we're going to do an assertions dot assert equals. So what is our expectation? If we have $10 in our bank account and we try to withdraw 100, then nothing should change. Our total should still be 10 because we don't have enough funds to take out 100. So let's actually check what our actual account balance is. Let's run this. And we can see that everything worked properly. Now, if I don't have to run our tests one by one, I can actually just run them all together, and you'll see everything is green. And I can tell you this is quite, it gives a lot of satisfaction when you write code and everything is a green check mark. That's another perk of actually writing tests. To show you the last one of the other perks of writing tests, I'm going to actually go to the self-checkout and I'm going to try to write a test for this one. So again, as we talked about, I can just click on the class name and then hit this little light bulb and I say create test, self-checkout test, and then I'll click OK. And it'll create it under my test folder. So I just open the self-checkout, I make sure I make this public. And then let's write a test here. Oh, my bad, I keep misclicking. So test, and then public void, and for this one I want to make sure that when we have products, the bag prices and the tax is all added together. So when buy 3 products, total sum is sum of tax and bags. So this is a test to check to make sure that we're adding the tax and we're adding the bag prices to whatever we're buying. So again, we're gonna create a self-checkout here. So self-checkout equals new self-checkout. And if you recall, we need the tax percentage and the bag price. So I'm going to give a tax percentage of 10%. And each bag price, I'm going to say it's $1. And now what we need to do is create a variable float total. And we're going to call the self-checkout checkout function that we wrote before. So we need the price of 3 items. So I'm going to give it 50. Let's say the first item we bought is 50, the other one is 10, and the other one is 30. And then I'm going to buy 10 bags. This way, the total is 100, and it's easier for me to calculate the tax. So $100 would be the total, and then we need to add 10% tax, so it would be 110. So what I want to do here is I want to make sure that the expected value here is 50 plus 10 plus 30, which is a 90, and then plus 10, which is 100. And then if you add 10% tax, because that's the tax that we gave it, it would equal 110. So what we're expecting is the result to be 110. So let's check the total that we calculated with the self-checkout and make sure that it equals 110. So if we run this test, we see that it's green and everything is working. Now the cool thing about tests is that if I actually go into my code, the self-checkout code, and let's say I'm thinking of, I have everything here where I'm calculating the sum of the items, the price of bags. Let's say I don't want to calculate the price of bags in the checkout function. I want to add another function saying calling it private and then float calculate bag sum. And then I take the number of bags as the variable. And then in this function, all I'm going to do is I'm going to do exactly this. So I'm going to take this code, copy it here, and then say return this. So instead of doing it here, I'm going to remove this line, and I'm going to call this calculate bag sum function, and I'm going to pass it the number of bags. So the reason I did this is because I wanted to separate this into a separate function to make it a bit more readable. So the person who's looking here doesn't need to know how we calculated bag sum, but they just know that we call this function and the bag sum is calculated. So even though we did that, it shouldn't change the results of this checkout function. And to ensure that happens, we can just run our test and we can make sure that everything is still working properly. So this is another advantage of tests. When you actually change your own code to make it more efficient, to make it look more clean and readable, you can just run your tests again and make sure everything is working. And this is really good for your own sanity because you can keep running the tests, make sure you didn't break anything and that everything is working properly. So this is why tests are so important and they are so good and they save you so much time, because maybe it takes some time to write these tests, but eventually in the long run, it will help you make sure that your code works properly and it's clean. So I can't emphasize enough from the get-go when you're learning programming, focus on tests, learn writing good tests and understand that they're for your own good and they help a lot. I hope you found this video helpful. Thanks for watching, and I'll see you in the next one.